Okay. So we need our calculators. Get out your calculators. I'll get out my calculator. Okay, so what we've got here, we have some data. We have some data about, what is it about here? Speed at various time intervals. And we just want to be able to make, ultimately we want to be able to make some kind of a prediction. This assignment doesn't even ask us to do that. It just wants us to go through the process of calculating the regressional models and then trying to decide, and then this isn't a question, but maybe we'll come to the conclusion, what's the best model here for us, okay? So, how do I do this? Why is it, there we go, okay. How do I do this? Where do I go on my, so we'll let the top, time is on the top row, speed is on the bottom row, so time will be like our x variable, right? And in our calculators, that's an important point. We don't want to change, we always just want to use the preset variables. You can change them, but it's really a pain to do, and there's no real benefit to it. We'll just always know that even if in our question that we're working on, they use different variables, x is our independent variable on the calculator, y is our dependent variable, okay? So where do I go on the calculator?
Stat edit.
Good, stat edit, okay, so we'll go stat edit, and let's go ahead and clear. So we're going to go to the header for each column and hit clear, enter. Clear, enter. Okay, and now we're just going to put this stuff in. So this is a little bit inconvenient because these are in rows and we're in columns, but that's all right. So this will be the equivalent of just going from there's the top of column 1, second entry, third entry, etc. So 1, 4, 8, 12, 14, 18, 20. Okay, scoot over, put in the y's. So 2.8, 10.8, 31.7, 58.3. Okay, you good? Ellen.
Second stat plot.
Okay. And before we even do that, let's go up to y equals, how about? And I'm going to go ahead and just clear all this stuff out of there. So clear. And then plot 1 is on, so we're good, right? So what was the way again? How do I focus? If I want to do a scatter plot first, how do I focus in on just my data? You remember? So I've got my data in there. If I want to look at it now, I can just go zoom 9. Yeah, zoom 9. Perfect. Okay, and there's my data. Okay, does it look linear to you?
No.
Not really. It definitely looks like there's some upward curvature, doesn't it? Yeah. So let's go ahead and go through, let's just calculate the regression models and see what we get. So if we go stat, calc, right, and then let's do the linear first. So just stat calc 4, and then we'll store this one, how about, as y1. So remember that's, where do I go to get that? The y variables? Alpha, trace, or F4, 1. Okay, go down. Okay, there it is. So while we're at it, how about if we just put in the answers on Moodle? Okay, so our linear regression model, and that's what that first question asked for, right? If the data is fit to a linear model, the regression equation is y equals, so we'll just put in what? We're supposed to round it to, and I kind of skipped through the instructions, but at the top it says round everything to 4 decimal places. Now, one nice thing I can do here too, there's a little trick on the calculator. I can go to, if that's the way the assignment is asking me to do, and maybe in real life there's a reason I wanted to do that, I can go to mode and just go down to the fix 4 option right there, hit enter, and now watch what it does. So if I quit, and if I just repeat my last command, that's kind of slick, isn't it? It rounds everything for me, 4 decimal places. Okay. So we end up with y equals what? What should I put in here? What's my linear regression model? AX plus B, good. So 9.2077 times x, or just x would be fine. Let's just put it x. Minus 28.0706. And r squared, my correlation coefficient, or correlation of determination, is what? It's like 0.9225. So always lead with a 0, 0.9225. And we're off to the next model, which is the quadratic model. Okay, so all I have to do there is, I guess we could take a quick look at the graph if we want to. There's my linear model. Not bad, but you can see it's definitely maybe missing the boat a little bit too. Do you expect, based on what we talked about on Friday, would you expect quadratic to be a lot higher r squared value? What do you think? This seemed pretty good, 92%-ish, close to 93. But based on the shape of that, do you think that's quadratic's going to do significantly better? Yeah. I bet it will. I bet it will. Let's just see what we get here. So if we go stat, calc, quadratic is 5. So stat calc 5, store it as y2. Okay. So what do I put in this time? Okay, I'm hearing it. I'm gonna move this guy. Okay, so now y equals ax squared plus bx plus c. You see that? It reminds us what the model is at the top. So 0.4913 x squared minus 1.1557 x plus 5.5645. Okay, and r squared 0.9982. Wow, that's pretty good, right? Probably quadratic's going to be good enough then. I mean, that's getting us really close to 1. If we look at a quick graph, there's the linear, which we could probably just get rid of, huh? Quadratic looks pretty good, doesn't it? Yeah. Just so we can finish up the questions, we probably wouldn't even need to necessarily do this. The next model is cubic. So we would just go calc. I could just type 6, couldn't I? Let's do that. Stat calc 6. Stored regression equation. That's alpha. And what do we get for cubic? So it went up a little bit, 0.9989 instead of 0.9982, but is that significant? Not really, is it? I mean, it's not worth having to use a more aggressive function. Remember, our goal is we want to use the least aggressive polynomial fit that does the job, which looks like it's quadratic. Okay, so y equals, real quick, that's kind of inconvenient that it pops up there. What's my answer on this one? Y equals 0.1 x. And being as they're trailing zeros, for my math calculation, it won't matter, right?
0.0.
Oh, 0.0. Whoops, you're right. Sorry. That 0 does matter, doesn't it? There we go. X cubed plus 0.1, what is it, 39 x squared plus 1.4991 x plus 1.3923. Okay, and my r squared 0.9989. Okay, last one. And we'll submit this and see if it works. So stat calc what? What number? 7. We're doing quartic, right? 4th degree polynomial fit. And do I even need to put the store regression equation in there, honestly? What's that good for? Yeah, just so I can see the graph, right? But in this case, I mean, maybe I don't even need to do that. We'll just skip down and do the calculate. Because we're pretty sure it's quadratic, aren't we? Yeah, and look again, it's really not improving that much. So quadratic is definitely the way to go here, isn't it? So we end up inconvenient. End up with y equals, and look at, I mean, even this isn't the main reason we don't do it, but even just dealing with these big polynomials is kind of cumbersome if we don't have to, right? We got all these terms and it's just a pain. So negative 0.0016 x to the 4th plus 0.0762 x cubed minus 0.7057 x squared plus 5 point, did I mess up? Oh, wow, yeah, I did. What's even going on there? X, that was cubed, wasn't it? Yeah, cubed. You must have been wondering, what is this guy doing? Minus 0.7057 x squared plus 5.5127 x. And then finally minus 2.6078. Okay? Whew. R squared 0.9993. Okay, here's the moment of truth. So I don't know what I hope happens here. Okay, so this is definitely our crappy Moodle that is causing this, because this one is on my test server, which is a different server, same Moodle, theoretically. So I need to work with people after school to get this thing going. So that's what it's supposed to do. Okay, it's not going to work for you at the moment, so let's do this instead. Why don't we're going to go to Plan B. Plan B for today is that. Just get in groups of, how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So how about 4 groups of 4? And just, whatever neighbors you're by, just make it easy. 4 groups of 4, get out one piece of paper and just do the assignment as a group today amongst yourselves. And here's the other thing. I don't want to make this busy work. And I think this assignment, a lot of parts of this assignment are busy work. So we're going to kind of change the directions a little bit. I don't want you to graph anything. Don't graph anything. Instead, why don't you just do this? Why don't you show me to demonstrate that you know what you're doing? And this is just a product of today's work. It's just going to be for each of these 3 problems, show me a scatter plot with maybe your 2 best candidates for the models. And then just why don't you, while you're at it, just kind of keep track of, start with the linear. And if the linear is like really close to 100% correlation and it looks linear, do you have to go any further? No, probably not. You're done, right? Then just show me a scatter plot with the line in there, write down what R squared is, and we'll call it good. Okay, move on to the next one. Kind of start with the lower level, the simpler polynomials, and if you're getting some traction, if you're actually getting significant improvements by moving up from a linear to a quadratic, then quadratic knocks out linear. If going to cubic does the same thing, then maybe you might want to make the jump from quadratic to cubic. Very seldom will you ever go to quartic, but maybe once in a while, but usually that's not necessary. Make sense? Okay. Sorry for this was sort of unplanned. I thought Moodle should have worked, as you can see, but it just didn't. So have at it.